Good morning, everyone. Welcome to the live session. I am Shubham, one of the student mentors of the Big Data Engineering program. So today we have Bhavesh Shah as our guest speaker. Bhavesh Shah is a cloud architect and a corporate trainer, AWS. He has worked with TCS as an AWS Solution Architect. So if you have gone through the mail that we have shared regarding this live session, then you must have come across a list of topics that are going to be discussed in this live session. So Bhavesh will be sharing his knowledge on the below mentioned topics and the topics I have mentioned here. And during the session, if you have any other queries or any doubts that you'd like to clarify, you can always post that on the chat applet. And we also have a content strategist of our team, Sandeep. So Sandeep will also try to resolve your queries over the chat applet. Okay, so please feel free to post your queries as the session goes. And Bhavesh will explain you a little bit more about how this Q&A process is going to be. So Bhavesh, welcome to this live session.
Hi, thanks Shubham for that quick introduction.
So Bhavesh, yes, you can.
Could you please give me the control, presenter control?
Bhavesh.
Okay, so I'll start sharing my screen. Yep, so I'm just a quick check. I hope I'm audible and the screen is visible.
Yes, you're audible. Bhavesh, and the screen is also visible.
All right. Good morning, guys, and welcome to the session of Amazon Web Services, mainly around cloud computing. Like Shubham has introduced, I'm a cloud architect and corporate trainer. I'm an ex-AWS employee and recently started out on my own into cloud consulting and training. Right. So the agenda for this session will be mainly around cloud. So first, I would like to answer the very common question that why cloud, and what are the benefits of cloud. Then we'll start the basics of cloud, right? What makes a service as a cloud service, or how do you qualify an existing service as a cloud service provider? We'll go through some of the cloud service provider, and then we'll start understanding how AWS allows you to use their services, what are the various services, how do you deploy your application, right? So in this session, what we're going to mainly focus on is compute, which you guys are kind of extensively using throughout your learning process at Upgrad, right? And I'll touch base upon virtualization, and then we'll go through a demo where I'll explain how to step by step launch an EC2 instance on AWS account. Okay, and at the end, I'll touch base upon how big data is relevant to cloud and how cloud, enables you to deploy and host big data analytics services at scale. Right. So with that, we're going to pretty much wrap up the session, and at the end, we'll have some time for Q&A. Right. So kindly keep posting your questions to Shubham and his team, and we'll answer these questions at the end. All right. So with that, let's get started. So first of all, in order to learn any service, I mean, cloud is a mainstream technology now. And you need to understand that why cloud has become such a disruptive force in the IT industry as of now. So the biggest benefit that cloud provides you today is your capital expenses translates to your operational cost, right? So allow me to explain this particular equation in a bit. So imagine that, let's take a live example. You guys are going to be with this program for, let's say, a few months, right? 6 months to 1 year. Imagine if you don't have cloud for your learning process, then you would have to procure enough hardware, or Upgrad would have to provide you enough hardware in order to deploy your learning process, the workloads, the assignments, and all. And after 1 year, probably you don't need that hardware. So whatever capital investment that you have done will all go for waste. Right? The same issue is with the enterprise today. So they purchase the hardware considering there'll be a good business or demand, but at the end, if the business does not turn up, their entire investment is gone for a toss. The other problem is that whenever you procure something in advance, you have to do the guessing on how much capacity to procure. And that's the problem with the industry. So the statistics that says that if a company is spending $100 million on data center, their actually ROI is 16 to 18%. So remaining 80% is a huge waste, right? And that's what cloud lets you do is you don't have to invest upfront. You start using cloud as a utility model. The way we use electricity, right? We don't care about how the electricity is generated, how it is maintained at all. We just use it, and at the end of the month we get a bill. And in summers we use AC. Yeah, we will get it from the grid, so we don't have to even manage the capacity, right? So I guess this is a real, I would say, to me, cloud more than a technical innovation, it's a business innovation at this particular equation. Your capital expenses translates to operational cost. But there are some other benefits also. So the per unit cost or the total cost of ownership for customers lower significantly because of the massive economies of scale. So if we talk about AWS, currently they are operating at 16 billion revenue with 45% year-on-year growth. So at that scale, they get all the hardware, they get all the components at a significantly lower rate than what a company can procure, right? Plus, yeah, they've done a lot of automation, so their overall time to market is significantly less, right? And you get it at the fraction of second. So lower cost because of the economies of scale. Now, for a lot of companies, managing data center is not their primary skill. For example, just imagine that if you were to select an insurance, let's say health insurance or a term plan, what would you do? You will select a term plan based on the features and based on the coverage that it provides. Or would you care about how a company manages the data center, how good they are at managing their IT? Right? So for these companies, a lot of companies, managing IT or managing data center is not their core business, and that becomes an inhibitor rather than an enabler, right? So with cloud, what companies can do is they can focus on their core business. They can innovate further and invest their resources on their core business and offload this undifferentiated heavy lifting, which is managing data center, over to a cloud provider, right? And that is where cloud is largely sold at the CXO level, because they understand the value of this overhead, and that's where the adoption is from top to bottom. So CXOs and CTOs, they define the cloud adoption roadmap, and then it's kind of adopted at the lower levels. The other technical advantage with cloud is that they have global footprint. So if we talk about AWS, they have 16 regions all across the globe, right? And you can choose to deploy it in any region. So for example, if your application works fine in one of the AWS region, you have a drop-in compatibility in any other region. Okay? I'm sorry, guys. I see a lot of pings here. I'm not able to see the chat window, so I'm just going to go and check if there is any specific message for me, or everything is all right. Shubham, I just want to understand, is everything all right, or should I?
Bhavesh, everything is all right. Okay.
All right. Okay. All right. Thanks. So, yeah. So we were talking about uniform platform and global footprint. So just to give you a real world example. So for example, Ola is one of the largest customer for AWS in India, right? So AWS launched a region in Mumbai somewhere around 2016. And before that, Ola was deployed in Singapore region, which was there for since 2010. So now with Indian region, what they've done is they're slowly migrating to Indian data center because of lower latency to their customers, and India is cheaper than Singapore, about 10%. Now, what they've done, so that migration is very seamless for them. I mean, definitely there is some challenge, but yeah, comparatively it is relatively seamless. Now, recently they've rolled out their services in Sydney or some other market. Imagine if you are not on cloud. In order to roll out something in a new territory, you will have to get into co-location agreement. You'll have to identify that right partners. You'll have to test out technically whether your application works fine or not. And then only you can make a call whether we can roll out the service in a particular region or not. But with cloud, they know that their application works perfectly fine in Singapore, in Mumbai region of AWS, and AWS already has a region in Sydney. So they have that confidence on technical level that the application will definitely work fine in Sydney. Yeah, it's just the business decision for them whether it makes sense to roll out a business in Sydney or not. So that is what the global footprint and the uniform platform gives an advantage to a lot of businesses today. If you want to expand your business, now it's no more a technical challenge for you, right? Otherwise, it takes a lot of effort, a lot of cost and time, right? And if you put all these things together, all the advantages put together, what gets is the speed and agility, the faster time to market for businesses, right? So we don't see many leaders now that they can see the future. They can say that next 5 years, my company is going to be in this direction, or I'll be heavily invested in this direction. The best strategy for most of the enterprise today is that adapt to the change, because the market dynamics are changing pretty rapidly. The flux is very high. That's where the best strategy that every enterprise they want is adapt to the change, right? Agility, how fast we can move, yeah, and adapt to the change. And that's what cloud gives you, because you use these services as a utility model. You don't have to heavily get invested on the infrastructure, on the technology, on the resources. You actually use it as a utility. And if it doesn't work, you just kind of release the resources, you stop paying for it. And if it works, you can scale out, scale up on that, and build your business on top of that. Right? So these are the real benefits that businesses are kind of getting it, and that's why cloud has become kind of new normal. I would say it's a mainstream technology, and every company in some or the other ways, even the banks, which are normally the last set of customers to adopt any new technology, but even the banks are heavily deployed on cloud. Okay, so what is cloud computing? So in a layman's term, if I were to define cloud computing, it's kind of a delivery of IT over the internet, right? And when I say IT, it's not just about servers or virtual machines, it's storage services, it's databases, right? It's kind of application development tool, it's data analytics, AI, machine learning, right? There are about 100 plus independent services in AWS that you can use in order to build your application, right? And similarly, there are other market kind of cloud providers which are on the similar lines, providing a lot of other services, right? So basically, delivery of IT over the internet. But these services are broadly classified into kind of three offering or service models, I would say. The infrastructure as a service. Let's start from the infrastructure as a service, right? So infrastructure as a service means you are procuring raw infrastructure from the cloud provider. And when I say raw infrastructure, these are kind of the virtual machines, raw storage, block storage, right? And networking and these things, right? So how infrastructure as a service is different from platform as a service. So platform as a service, you actually are looking for a platform where you can deploy your application. So you don't want to be bothered about how the platform is maintained, what kind of servers are running behind the scene, who will manage the availability, scalability, right? So that the platform provider takes care of it. Just in case, I mean, let's take an example. If you were to deploy a database, for an example, you have two options. One is either you procure kind of EC2 instances, I would say virtual machines, right? You set up your networking, you design an architecture, you deploy your database on the operating system, manage the backups, manage the scaling, yeah, and manage the recovery and high availability on your own. So that will be like infrastructure as a service implementation for database. But if you are not doing any deep customization around the core topology, then it would make sense that you go for platform as a service. If it's just a generic deployment, let's say an Oracle database, yeah, which is pretty generic and standard configuration if you want to use. So you can use a platform as a service where AWS is going to manage the setup, installation, hardware, scaling, backup, recovery, and 99.99 uptime. Okay, so you basically kind of use it as a platform where platform provider manages the availability, scalability, and the fault tolerance of the system, right? So it's a higher level of abstraction. Sorry, it's a higher level of abstraction as we move from infrastructure as a service to platform as a service to software as a service, right? And software as a service means you're going to use that particular service from a browser as an end user, right? Like ERP, like Office 365. Yeah. So these are kind of the software as a service. Now, how do you decide, let's say, database on EC2 or database on virtual machine as an infrastructure as a service, or a database as a platform as a service? Similarly for compute, similarly for analytics. How do you decide? So basically, infrastructure as a service is going to give you more control on how do you design your entire system. Okay? And as you move towards platform as a service and software as a service, you trade off that control with convenience. So you gain the convenience of the platform and you lose the control on how internally it is designed, right? So if you're just deploying something, a generic, component or software, you can very well choose a platform as a service. And if you're making any technical innovation at the core layer on the topology or on the optimization on the software, then probably you can go for infrastructure. If that is your IP, if that innovation is your IP, then you should go for infrastructure as a service. All right. So control versus convenience is the trade-off that you need to take care while selecting the same service under different model. Okay. Now, so let's try and define. I mean, academically, there are some characteristics of cloud. So every company nowadays says that, yeah, we are cloud provider, right? We are a cloud company. But in order to truly identify whether a company is a cloud provider or not, there are characteristics that you need to identify, right? So let me quickly go through these characteristics. So the first characteristics is you will have to, I mean, this cloud provider should have an on-demand self-service model. So it should not be the case where you have to call somebody or you have to raise a ticket in order to get a server provision for you, and the server will be like within half an hour or 1 hour, right? No, whatever you need, you get a self-service portal where you provision things and it should be available within minutes. Yeah. So self-service, on-demand self-service portal is the first characteristics. Second, rapid elasticity. So whenever you need more infrastructure, you should be able to get it. So cloud providers, they say they are virtually unlimited capacity. Yeah. Yeah. So that's where you should have rapid elasticity. So whenever you need more resources, you should be able to easily provision that. Third, you will pay only for what you use. So whatever you use has to be metered, and based on the usage only, your kind of your charges should be there, right? So though cloud providers have different pricing model, right? But the basic on-demand pricing, that means you provision something, use it for a few hours, release it, and you are only billed for that many hours, right? So that is again core to. And one more thing is that how does cloud deliver all these benefits? Because behind the scene, it is resource pooling. So as a customer, you have to be aware of the fact that you are in a multi-tenant system. All right. The way you use Ola or Uber, right? It's not your car. You're just kind of using it for a journey. And after that, somebody else is going to use it. So similarly, if you deploy an application on your server, that is not your server. Yeah. When you release it, that server will be given to someone else. And that's where you need to make sure that you kind of take care of the data security on cloud. Yeah, because it's a multi-tenant system. Behind the scene, it is resource pooling. And ultimately, the platform should have broad network access and multiple interfaces, right? So that it can be used from anywhere over the internet from multiple devices. Okay. So I think to summarize this entire kind of talk, We talked about benefits of cloud. So why cloud? What is cloud? Yeah, and how to define a cloud service provider. Okay. Now let's kind of go through some of the other terminologies that you'll come across if you work with cloud computing or cloud deployments. So the uh, the real momentum that has been brought into IT for cloud is from the public cloud providers, right? So they are the kind of real stars, I would say, in the cloud environment, namely Google. I mean, AWS being the pioneer, Google, Azure. Now even Oracle is coming up with Ali Cloud, Alibaba is there, and there are a lot of other cloud providers also in kind of specific territories in US, in Europe, and all. So public cloud is what gives you all the benefits that we talked about. But a lot of companies are heavily invested into data centers, right? And it's a $3 trillion economy, basically. It's a market, right? So they're heavily invested into data center, and they're not going to overnight migrate over to public cloud. So they have their own data center. Now, there are a lot of software providers that are supporting the data center in terms of the virtualization, in terms of the network, in terms of the storage systems, right? So VMware, Cisco, NetApp, Hitachi, and all. So what they've done is that whatever they were doing manually on their own data center, now they've tried to automate it, and they're naming it as private cloud. Okay, so you get the benefit of the automation, but not the real benefit of capex versus opex. But still, they're calling it as private cloud, right? So there are a lot of private cloud providers like VMware. Even Azure has something called as Azure Stacks and OpenStack, and there are a lot of private cloud providers. Okay, but the problem with the private cloud is that you still have to have the physical capacity procured before you can deploy those softwares, orchestration. So we have something called as private cloud, we have something called as public cloud. What the large enterprises they're going to be is they'll be on a hybrid model where their existing applications will be on private cloud, and slowly they will keep migrating their applications onto public cloud. So that model is called as hybrid cloud. But when we look at the startup ecosystem, they are born in cloud and they are all in cloud, and mainly around public cloud. All right, so whenever you come across these three terms, don't get confused, right? Public cloud is what is the real cloud. Private cloud is an automation on the proprietary data, I mean on-prem database data center, sorry. And the hybrid cloud is an arrangement where application can leverage both of these, private as well as public cloud. All right, so a quick look at the market on the cloud providers. So AWS leads the cloud market. So they are the pioneer and most mature cloud. At present, they have 34% market share. Second is Azure. So now a lot of companies they've started looking into multi-cloud strategy, because every large company will have a multi-vendor policy, right? So normally, most of the cases, AWS is the first vendor, and then Azure or Google becomes the second vendor. But in some cases, because Microsoft has a deep presence into the entire kind of IT world, that's where in some cases even Azure is the first vendor. But largely the space is kind of lead or ruled by AWS. Okay. And Google is, I would say, the so though IBM has good revenues, but I think Google is in true sense making real impact in public cloud space. So I would consider it as AWS, Azure, and Google. I mean, between these three players, and then we might get, let's say, we might get Ali Cloud, we might get Oracle into this. But right now, these are the three prominent players here. So quickly, a few slides on what kind of customers they're using cloud. So first of all, like I said, for startups, cloud is a necessity, because they are working on something which is not kind of already proven, not already tested, right? So they don't have a clear roadmap, and they cannot invest. Clear roadmap in a sense, they don't have ability to guess capacity, invest in something which is not proven. So that's where cloud gives them this ability to start small and scale big if it works for them, right? And they need to be agile because they'll be making a lot of changes in their application strategy, right? And that's where cloud for startup is like a necessity. So almost, I mean, we'll have to ask this question that which startup is not deployed on cloud? Yeah, because more than 90% startups are on some of the other clouds and largely they're on AWS. Then, since last 5 years, even the enterprises started looking at the benefits that startup ecosystems are getting from cloud, and that's where almost all the enterprises now at this moment has some kind of some or other roadmap on cloud adoption. So if I give you an example, GE um, gave a statement in 2015 that they will be migrating 6,000 applications, 6,000 workloads on cloud, and they'll be downsizing their data center footprint from 34 to just 4, right? So, and they'll be moving the remaining infrastructure on cloud. So that's the kind of G is kind of probably one of the largest consumer of IT, and they having kind of this kind of aggressive roadmap on cloud. So every company and um, yeah, that's where cloud actually is really in demand. Okay. Not only that, even some of the government agency and federal agencies in US, they are deployed on cloud. So some of these agencies are kind of considered as highly secretive on the kind of workload, the kind of projects that they work, applications that they work, but still they're using cloud. So security may not be kind of the way people perceive security in cloud is not the right perception, right? What AWS has done specifically for federal government agencies is that they have set up a isolated cloud. I mean, it's a separate data center where only federal government applications are deployed, right? But still, I worked in Singapore for 5 years, and I know that a lot of Singapore government workloads and applications are deployed on AWS, right? So even a lot of government agencies are also, and in India also, Microsoft is leading the kind of government strategy on moving digital India, right? So Microsoft is leading it. AWS has recently got all the kind of necessary accreditation for running government workloads, right? So the space is kind of now being used by almost every type and every kind of companies as well as startups. So that's like cloud is now mainstream technology. Okay. All right. So with that, I would like to take a 10-second pause, and before we move on to the AWS, and would like to talk about a little bit about what is in for you, and especially for big data in cloud, right? So, from my experience of working with large enterprises outside India, like GE, Procter and Gamble, and P&G, I mean Unilever and all, and in India, when I was at AWS with some of the banks, some of the large customers, um, their primary workloads are digital assets, web applications, and analytics. Yeah. So analytics are their kind of one of the kind of most three important workloads that will be moving to cloud, and that's where big data on cloud makes a really important kind of strategy for them. So we'll talk about this more towards the end of this module, but the challenge here with the industry is that they don't have right skilled people. And if you go through some of the reports, data science and cloud computing, these are some of the two most highly paid jobs, right? So it makes sense for you guys. I mean, you've chosen the right direction to have a career in data science, and there you will have a little bit of cloud, and probably you can kind of, once you get the comfortability, you can grow yourself in cloud as well as big data, right? So that's the current state of industry and demand in market. All right. So with that, let's try and understand AWS. So why we have chosen AWS? Because AWS is the market leader, they're pioneer and most feature-rich platform on this planet, right? So AWS had launched publicly. I would say AWS was launched in 2006 with a vision to enable businesses and developers to be able to build web scale applications. So from their learning and challenges that they face running the largest e-commerce system, e-commerce platform or company, they were trying to give the same scale or same services building blocks to their customers so that they can achieve, this kind of sophisticated web application. So they started with S3 as the first service, and then after 6 months they launched EC2, which is a server kind of virtual machine in cloud, right? And at present they have more than 100 services and in total 2000 plus features. So you name a building block that you need for building a web scale application, AWS has a service for it, right? So there used to be a saying like you name it and Apple has a kind of, there is an app for it, right? So now I can say, being a cloud consultant, that you name a component and you probably find a service in cloud. Yeah, maybe in AWS, Google, or Azure. So that's a kind of, but they're still evolving. They're still evolving. Now, like I said, AWS has got 16 regions, and they keep adding more regions, right? So this count could be changed, let's say a few months down the line, right? So they keep adding more regions, and AWS CEO has a vision to have one region in every major country across the globe. So now these regions has something is collection of something called as availability zones. So in total, they have 46 plus availability zones, and these availability zones are kind of independent data centers, right? Yeah. On top of that, they have something called as an extended infrastructure, which is an edge location, which is their content delivery network. Okay. So I'm going to briefly explain. This is really very important to understand at a very high level what are the availability zones and what are the edge locations, because then only you can leverage the true nature of cloud and build high availability and fault tolerance into your application. Okay, so 2 slides on high availability and edge location. So let's talk about Mumbai region. So every region, or any region I would say, in AWS must have 2 availability zones, and these availability zones are independent data centers. Okay, now there are some rules that any region should abide by. So first of all, these 2 data centers should be 10 to 100 miles apart from each other. Ideally, they should be in a different seismic zone for fault isolation due to any natural calamity, but they should be at least 10 and max 100 miles apart from each other. Okay, they are kind of isolated, fault isolated at the network level, at the internet connectivity level, at the power grid, right? So any external failure, should not impact the availability of this data center. So for example, if I talk about power grid connection, they'll be taking power grid connection from multiple providers. Like in Mumbai, we have Torrent, Reliance, Tata, right? Master government. So redundancy and avoiding single point of failure. So they maintain the high availability at every level. Okay. Now, so fault isolation across these 2 data centers within a region. At the same time, they have low latency connectivity between these 2 data centers. So you get a single digit millisecond latency between any 2 availability zones within the region. Okay. Yeah. So with dark fiber, and any data that you store within a region does not leave the region by default. Okay. So the objective of having 2 data centers within a region is to achieve high availability, fault tolerance. Okay. Yeah. You can find out more on this on YouTube videos, or if you're interested, you can read some, some of the pages on aws.amazon.com, which will explain what is the real reason and how customers are leveraging it. In the kind of larger interest of this session, where we are mainly focused into EC2, so I'll kind of quickly want to go to EC2, right? The second set of infrastructure, I would say extended infrastructure, that AWS has something called as edge location or edge cache, right? This is the content delivery network, primarily used for content delivery networks. So if you've heard about Akamai and Cloudflare, content delivery network. So AWS has a service called as CloudFront, which is a content delivery network. that kind of accelerates delivery of your static content as well as dynamic content, right? As at the same time, it is being used for a DNS service. All right, so I'll not go in depth about these services. You can actually go and read about this if you kind of feel like interesting. Now let's go to the main service, which is kind of the focus of this particular session. So EC2, Elastic Compute Cloud. What is an EC2 service? So EC2 allows you to provision virtual machines on AWS platform running on AWS hypervisor. All right. Now let me first explain. Let's first understand what is virtualization and what is hypervisor. So uh, let's do this. I mean, can you quickly look at your CPU utilization? So on your laptop, just look at the CPU utilization. It will be less than 10%. Yeah. Similarly, all the data center hardwares, I'm talking about something 10 years ago, 10, 20 years ago, right? So previously, when you were to build data center, you were to physically procure the hardware, set up the networking and deploy your application, right? So every physical hardware was a single operating system server. Right? But the point here is where you deploy an application. But the point here is that the hardware was underutilized. Yeah. So then the companies, they started thinking about this problem, and they kind of came up with something called as virtualizing the hardware. So now at present, what do you see? You have a physical server, yeah, which will have a lot of memory, a lot of CPUs, and some internal storage. Then there are softwares called as hypervisor. So you deploy your hypervisor on a bare metal physical server, and these hypervisor will let you create a virtual machine where you can have your operating system. So when you launch a virtual machine, what hypervisor does, it allocates some CPU, some memory, and some storage based on the configuration that you select. Yeah, it is going to virtualize the hardware, allocate some capacity to you. Yeah. So here the important part here is that the remaining capacity can be used to virtualize other servers. And the beauty of these hypervisors or the virtualization software is that application won't feel as if they are running on kind of another layer of software. Okay. So the entire motive of having hypervisor or virtualization is to improve the hardware utilization. All right. And then slowly to achieve better automation, better manageability of the server. So now with hypervisor, you don't even have to touch the server physically. You can just provision servers, yeah, with a console. Let's say the most popular software is VMware, and then there are kind of Hyper-V, Zen from Citrix. So there are a lot of hypervisors. Yeah. So it makes the entire hardware management pretty easy in the data center, right? So whenever you launch an EC2 instance in AWS, what you're doing ultimately is you're actually provisioning a virtual machine on the AWS hypervisor, which will allocate you some CPU, some memory, and if there is any disk. Okay, and then again every server will get some network connectivity, and from there they access the external storage, which is called a SAN storage, which is an elastic block storage, I would say, in terms of the AWS service. Yeah, but the generic name is storage area network or SAN storage in the industry term. And with the same network, your server can access other AWS services and even can reach out to internet. Okay? And as an optimization, you can even have dedicated connectivity to your storage. So now, why I'm explaining EBS here? Because your operating system is going to be residing on an external storage. Yeah, yeah, and that is something called as EBS. So EC2 and EBS are kind of that is something which gives you an ability to stop and start your instance, which you're going to talk about. Okay, so this slide, my main focus is to explain you what is virtualization, how the hypervisors work, and when you launch an EC2 instance, what happens behind the scene. All right, so AWS APIs will let you provision an instance. So you fire a command, or you kind of click on your UI that translates into an API call in AWS platform, which internally calls a hypervisor, and the hypervisor allocates some resources, and you get a server up and running, right, in few minutes. Okay, so now let's understand, this is kind of how the EC2 instance is built internally. But when you deploy it, when you provision it, where does it go in the AWS world of regions and availability zones? So when you launch an instance, you will have to launch it via image. Okay? What is an image? So image is a pre-bundled copy of your operating system. At the same time, it can also have pre-configured software installation. All right. So it's like a copy of your system. Bare minimum, it should have an operating system, and on top of that, it can also have kind of data. It can have software installation. Right. So you guys are using Cloudera VM, right? So that is actually an image. So that image that you deploy, you get a pre-bundled software that you can just use right out of the box, right? You don't have to log into your operating system, configure, deploy, install the software, do the kind of configuration. No, you get it pre-packaged as part of the image. Image is kind of copy of a existing instance which was configured with the necessary software, right? So image is something that you need, and you launch an EC2 instance with an image, right? And the EC2 instance is going to be deployed in one data center, or I would say one availability zone within an AWS region, within a VPC. All right. So when you guys are launching an EC2 instance, you might be launching it in a default VPC within a subnet, which is ultimately an availability zone. Okay. Yeah. So this is the process in which an AMI will let you launch an instance which will actually be placed on an AWS region within an availability zone in a single data center, okay, within a VPC, of course. All right, so let me do one thing. Let me launch an EC2 instance and kind of revisit all these topics that we've talked about and see how it works in the real world scenario in the console. So I will have to, okay. I hope you are able to see my screen. A quick check, Shubham.
Bhavesh, your screen is visible.
All right, good, great. Okay, so guys, this is how, I guess you all have AWS accounts, right? So this is how you will be kind of seeing the screen once you log into AWS account. Here are all the regions that we talked about, right? So from a single window, I can say that, okay, I want to deploy something in Mumbai. Okay, now if any service that I deploy will be physically deployed in the Mumbai data center. Okay? And then you can see your billing from here, right? If you run into any issues, you can reach out to support center, raise a ticket, and then here are all the services, right? And you will see most recently used services if you want to quickly kind of navigate across multiple services. So what I'm going to do, look, all the services that AWS provides you are kind of nicely grouped into various categories, right? And what we're going to do is we're going to go through EC2. You can even search for compute EC2. Okay? So that was the general dashboard. And when you go to the service, when you go to a specific service, you're actually redirected to a service dashboard. And on the left-hand side, you will see all the features of that particular service, right? So when we talk about 2000 plus features, these are the features that I was referring to. So what you can do, first of all, this dashboard is going to give you a quick view of what are the kind of resources that are running in your account. Okay, and you can even go to the instances and see the details. What instances are running currently. Okay, we're going to launch an instance. Okay, so launching an instance is a step-by-step process. Okay, so the first step for you is to select an image. Okay, so there are a lot of pre-configured plain operating systems that AWS supports, and the other technology providers have offered it on AWS platform. So for example, Red Hat, Windows, right? Ubuntu, and Amazon has its own Linux, SUSE Linux, right? So this is going to be a plain vanilla operating system. But I want to, let's say, run a blog or run a WordPress um, server, for an example, right? Just to make sure that I show you something beautiful once we have the server launched. So what I'm going to do, I'm going to go to the marketplace and I'm going to search for WordPress, right? And there'll be a lot of uh, images from different kind of providers, right? So Bitnami and Animoto and all, right? So I'm going to just select this. So look, there is no software cost. It's an open source software. You only pay for the AWS usage. And you can select this image. It is going to again ask you for a confirmation that this is what you're going to pay when you launch a specific instance size. Okay. Yeah. AWS allows you to launch instances from a micro instance with half a GB RAM and very small CPU to something like 256 vCPUs and 2 TB of RAM and everything in between, right? So there are a lot of sizes that you can choose from. Now I'm going to continue. So I've selected an image which has got it's LAMP stack basically. It has got a Linux operating system and it has a pre-bundled WordPress software. So this is my image. Now the second step for me is to select the size of my server, right? And like I said, from a micro instance to extremely large capacity, right? So 128 and 2 TB. Yeah, and even there are larger instances available. Okay, so I'm going to go ahead with the free eligible, which is T2 micro. Okay, so please select this and go to the next. Now in third step, you provide the network placement for your EC2 instance, right? So since 2010-11, AWS has mandated that any new customer will have to launch their newly launched instances in a VPC, okay, within a virtual private cloud, which is your network. So every region has a default VPC, okay, and that's where probably because you're not familiar with networking on AWS, that's where I would want to go ahead with the default VPC. And look, there are subnets in each availability zone. So Mumbai has got two availability zones. Yeah. AP-South-1 is the region code for Mumbai, and there are two availability zones, A and B. Okay. So you can select any availability zone. Both the subnets are public. That means you will get a public IP from which you can access your server. Yeah. And for now, I think that's enough for you. Right. So you can launch. You can define the networking for your EC2 instance and availability zone indirectly. Third is, look, your root volume or your kind of operating system. Yeah, so in Linux we call it as root volume. In Windows, let's say C drive. Okay. So this is going to be created from the image. So like I said, image is a copy of your OS and the install software. So image is going to provision this root volume, which will be on EBS. Okay. If you want any additional storage, you can add it. All right, but just be careful because this will be charged separately. Okay. So I think up to 30 GB you can use it under free usage, and beyond that it'll be being separate. All right. Now tags. So tags does not have any technical importance, but it is good practice to kind of provide some additional information to your resources so that you can group them, you can identify them, and you can search them. Let's say if you run 100 instances, how do you identify which one was a Cloudera image? Just looking at the console, not logging into EC2 instance. So for example, I'm going to say this is a application WordPress and environment. It's a demo environment. Okay. The tag does not have any technical importance, but yeah, I think they're very important to kind of classify your infrastructure, especially in a large deployment, large environment. Okay, so this is again a very important aspect. Security group, which is a firewall. Okay, so I'm going to just make it simple, remove everything in order to explain this what we are trying to do here. So you will have to create a firewall on your EC2 instance. By default, AWS blocks all the incoming port on your EC2 instance. So nobody is going to hit your EC2 instance, and that is for security reason. Yeah. So as a customer, uh, I'm running a web server. So I'm going to create a security group for my web server. Now, what ports should I allow traffic to be received on? Okay. So very natural that it is going to be HTTP from any IP over the internet, and it should can be HTTPS if you're actually running on 443, right? So again, from anywhere over the internet. Now, how do you log in remotely to a Linux server? You would want to do SSH, right? So you can also open SSH, but from a limited network. So only from your network you would want to. So this is your network IP. Okay. So only from this IP you want to be able to access. Yeah. Yeah. Don't keep it from anywhere. This is again a security, right? It gives you a warning. It is good to have a custom range or a smaller IP range, okay? And best to have a single IP. So this is a firewall setup. So now nobody can hit my server except, sorry, this should be HTTPS, except 80, 443, and 22. Okay, so no other ports are open. All the traffic will be dropped, and this is what a firewall is called. Right. Ultimately, I review and I launch an instance. Right now, when I launch an instance, it is going to ask me for a key pair. Right now, this is a replacement for a human readable password. So normally, how do you log into your OS? Yeah, you have a username and password, but password can be guessed. I mean, anybody can guess, try a brute force attack, and try and kind of hack your system. So what AWS has done for better security is that they use a key pair where the private key will be with you. So you can generate a key, you can give a name, and you will have to download that key. Right? So now you have the private key, yeah, that I'm going to share here. Sorry, save here on, let's say, my board. And AWS keeps the public key. So private key, public key. Read more about private key, public key authentication if you're interested how it works behind the scene. But AWS does not keep your private key, and that's where if you lose out the private key, you'll not be able to log into EC2 instance. You can recover your server, but you'll not be able to do the operating system level authentication. And no system in AWS, no employee of AWS can do that for you. So I'm launching this instance with a newly created key pair. So AWS is going to inject the public key within the Linux box. And then whenever you want to SSH into that server, you will have to use the key that you just now downloaded. Okay. So this launch process is going to take a while. Yeah. And this is the instance ID that is being launched for me. All right, so I have one running instance here, and it is initializing. Okay, so here on the bottom of the screen, you will see all the details about this instance. Yeah, so what is the ID, what is the size, in which availability zone, what is the security group that you set up, from which image, key pair, what are the volumes, and most importantly, the IPs, right? So with this IP, you actually access your system, right? So with this IP or DNS, You can use any of these. Yeah. So I'll wait for this instance to be up and running. Yeah, because we have a complete software, right? And what I'll do, I'll just go back to the slides where I'm going to explain what are the various states of these instance. Okay. So let me just try. Let me just try accessing it. All right, look, within less than a minute, I got this instance up and running. So WordPress blog is ready. Yeah. And you can actually, and start using it. All right. Yep. So this is how you launch an EC2 instance. All right. Yeah. So quickly, let me go back to slides, and so here, look, how do you, once you're done with this instance, how do you kind of release this instance? So you have terminate, you have stop, and you have reboot. So in next slide, I'm going to explain what does this mean. Okay. Yeah. So let's go back to the slides and let me explain in the EC2 instance lifecycle. So like we did, we launched an EC2 instance from an image and it went into running state, right? And while you have an instance in running state, your billing starts. Yeah, you can access it, you can use it. Instance is up and running, all for yours. But let's say you're done with your task or your exercise. Yeah, you want to release this server, you want to stop paying for it. So what do? You actually click on terminate instance, and the instance will be terminated. Now, when you terminate an instance, AWS is going to release the hardware completely, release the IPs, even private IP and everything, right? So it will destroy the entire instance. And if you want to get that instance again, you'll have to go to the launch process, yeah, from scratch. So you'll have to launch a new instance. You will get a new private IP, new public, everything new. So terminating means completely destroying the instance. Okay. But now, let's say you're doing an exercise, okay, and that has a dependency on your next exercise. So what you can do is you can complete your first exercise and then stop your instance. Okay. Now, when you stop your instance, AWS keeps your operating system configuration, your software installation, your state of the system stored on EBS, which is an external storage. Okay. Yeah. And it will release the hardware, release the CPU memory for you. So you stop paying for your compute, you still pay for the storage, and your state is preserved. So now let's say next day when you start doing your lab 2 or exercise 2, you want to have the server up and running again because you have some dependency. You can actually start the server again and you will get the exact same state. Yeah, you don't have to rebuild the entire server. Plus the benefit here is that when you stop an instance, your billing for your EC2 instance stops, which is per hour or per second billing. Yeah, so it stops. So you save a lot of cost without losing your operating system state or your data. All right. So that's where cloud is really beneficial. So when you're not utilizing your resources, you can release them and you stop paying for them. Yeah. And there is a small operation there, reboot. So reboot actually is, does not make any change. Okay. In reboot, you're just rebooting the operating system via hypervisor, right? But I just want to explain that reboot is also an operation where let's say you run into some issues, your operating system does not perform well, then you just want to reboot from console. Okay, that is a best practice rather than rebooting from your operating system. And when your instance is in stop state, and let's say after a few, let's say weeks, you realize that, okay, I don't need this instance, you can even terminate it from the stop state. So AWS is going to release everything, destroy everything. Okay, so this is pretty much the EC2 instance lifecycle. All right, so let me go back to the console. Let me try and stop the instance. Okay, so I can stop this instance. Yeah. and I'll not be able to access this instance, but I'll have the ID preserved. I'll have all the other information preserved, even private IPs, except for public IPs. Okay? So public IPs are also released because they are a scarce. IPv4 is a scarce kind of resource. Okay, so if I try and hit this server, I'll not get any response now because now the server actually is in a stop state. Okay? All right. Okay, so look, my public IPs are gone, right? What I can do now, I can again go to the instance and click start, and instance will again come up. I'll get new IPs and I'll get the same state of the server and my applications. All right, so like I said, this is going to take 30 seconds or a minute. Okay, so look, I got a new set of IPs, and let me try and see. It is going to take some time. Okay, so look, my server, everything is in the same state. Yeah. All right, so with that, and ultimately what we do when we are done with the server, it is a good practice to terminate it because I know that I'm not going to use it. Yeah. So I terminate it. Okay. And I completely kind of release all private IPs, everything. Basically, it's kind of destroying the server. All right, so that was all about EC2. Let me just quickly uh, explain how big data works in cloud or in general. So there are 4 steps in any big data kind of engineering. So you need to have a strategy to collect fast moving data, high volume, variety, velocity, kind of all the V's. Yeah, you'll have to have extremely scalable storage. Then you'll have to have the techniques, tools, and frameworks to analyze the data. And every use case requires a different framework. And ultimately, you have a lot of other tools to visualize your analysis or insights. Okay? And I guess you guys are mainly focused on the storage and analysis. Yeah, and that's where even Hadoop is mainly focused on. So when we talk about Hadoop distributions, you guys have heard about Cloudera, Hortonworks and MapR, right? So when I say distribution, Hadoop actually is an open source framework, right? But when we talk about distribution, these are the pre-packaged kind of installation, pre-packaged installation with the right selection of tools for specific use cases. Yeah. So then which one to select for if all are based on Hadoop? So Cloudera is the pioneer in big data. So they have a huge presence in industry and their skill set are readily available. That's why a lot of enterprises they go with Cloudera. And they have a hybrid model or freemium model. So they have the core basic kind of distribution as a free offering, but they have a lot of other tools to manage the ecosystem, right? So Cloudera is kind of a kind of a mixed, a little bit of proprietary and core on Hadoop ecosystem. Plus, one downside of Cloudera is that the availability of new features in the Hadoop ecosystem are kind of available on Cloudera a little later because they test it out on their existing ecosystem, on the tools that they have, proprietary tools that they have developed. The other one that you have heard about is Hortonworks. So Hortonworks is completely open source, and the features that are kind of rolled out in Hadoop ecosystem are pretty much available immediately on Hortonworks, right? So for them, they don't have any proprietary tools. They just kind of their business model is kind of support. They provide support for so it's a pretty open ecosystem, and there is a lot of adoption on Hortonworks also. What MapR has done is they have actually rewritten the entire HDFS layer with C coding. Basically, they're optimized. They claim that they've optimized it significantly, but it's a proprietary kind of offering. So the companies who are specifically looking on certain use cases where they can leverage the performance and proprietary implementation from MapR, those are going for MapR, right? So I guess there are some pros and cons in each and every each and every offering or distribution. But Cloudera is what generally kind of widely used. Cloudera Hortonworks. So yeah, with that, I'm done with this webinar, and I'll be open for question and answer. So I would request you guys to provide your feedback on this particular URL. I'll do one thing. I'll share it on the chat window, or if you can note it down, bit.do/cloud-feedback. All right, and you can reach out to me on LinkedIn, or you have my you can reach out to me on my website cloudart.in for any specific questions. Yeah, and I think Shubham, we can open for general Q&A.
Bhavesh, a lot of students have sent us questions, so I will be sharing those questions with you one by one. Okay. Okay. So. So Bhavesh, here's the first question. If you can look at the chat.
Should service provider take care of ensuring data is not shared across various customers? So yes, they do. In fact, security is their biggest concern. But would you go by what? So first of all, look, how does it work? So they are certified by a lot of industry standards and accreditation, like SOC 1, SOC 2, HIPAA, and all, right? But even though they are certified on that, you being a customer, whenever you put, so for example, you put your valuables in locker. If I open a bank, let's say, what we say, let's say a cooperative bank. Yeah, I also provide locker service. My cost is less. And on the other side, you have like SBI, HDFC, Axis Bank, and So which one you is going to go for, right? You're going to definitely select and go through that. What are the security mechanism, how it is done, and even though whenever you put your valuables in locker, you'll also lock your kind of jewelry box or something, right? You're not just going to kind of keep it just like that. So it's like that. Though cloud providers are doing enough to make sure that the data is not shared, the isolation is there, but still, as a customer, you will have to take care of your data. Yeah, because there are certain beyond certain limits, even technology and science fails, right? That's where hackers they get advantage, right? So there are a lot of things that you can do proactively as a preventive measure. Okay. Second is, do we have any standard security specification to which client service provider adhere to? There are a lot of things. So security is not a pluggable, service. You cannot say that if you do this, you will be secure. You can always increase the probability of security. Okay. Yeah, and there are always new things coming up, right? And that's where it's a continuous kind of process, right? So there are a lot of things which are there which you should always implement, but then again every application demands a separate or a different level of security implementation, right? For example, a media company wouldn't bother about their video security of their video files, whereas security in a sense if that video gets kind of stolen or what. But let's say if a bank or a Salesforce like organization where you have contracts stored on the CRM, they would be concerned about the security. Okay, so they would want to kind of make sure that the data is, even if it is stolen, it is not visible or readable. Right? So that's the level of security. Do we have any case study where we can compare the TCO of managing? Yes. I mean, the cloud, this was like 6 years ago. All right. So you can find a lot of articles on TCO, total cost of ownership, on um, cloud versus the on-prem, right? And various cloud providers, and they have their different mechanism. Even nowadays, actually, I'm working on a tool where cross-cloud comparison, right? So you can compare Azure versus AWS. So now this is an old topic. So people now believe, and they've kind of verified that cloud is cheaper than more kind of cost effective than on-prem. Now the comparison between multiple clouds, right? So whether AWS, Google, Azure, Ali Cloud, and all. Right? So yeah, it is there. What are the risks with public cloud? Well, yeah. So it, how do I say this, right? If you don't implement it, yeah, right, yeah. So let me put it this way. So a lot of customers they say that um, cloud actually improves their security profile because AWS or the players like Google, AWS, and Microsoft, they can invest a lot more on security than what you as an individual can do in as a company. But it's about the implementation. It's about the architecture. Okay, and yeah, if you don't implement it right, then you will be at risk definitely. So from the security point of view, it's about the implementation. But the other risk is vendor lock-in, right? So because now cloud services they're coming up with their own kind of platform as a service, their own implementation of a certain areas like analytics, data ingestion, machine learning. Right? So if you are into a particular platform, and let's say tomorrow you want to kind of leave that platform, move to another platform, then you will have to again think about all the transformation or migration exercise that you have to do. So again, that is a trade-off whether you go native and achieve the best performance, or you have a generic implementation which can be built on top of any cloud. Okay? So if private cloud is just a data center with a private line for that organization, why call it as cloud? Yeah. So AWS does not believe in the word called as private cloud, but industry has come up with this, right? And that's where they call it as private cloud because it lets them orchestrate, automate, and provision the resources. It's just that the equation of capex versus opex is not implemented, but still they want to kind of have that self fulfillment to be called as private cloud, right? And they want to. It's a sales piece basically. Right? But AWS they do not believe in private cloud. They don't say there is something called as private cloud. What if data localization law gets enforced by more countries? Do you think this is a potential risk? So remember, if one sentence that I said is that any region you store your data in any region by default does not leave that region. So that's how AWS takes care of that compliance. Yeah, by default your data does not leave that region, the data residency. Okay, so it's as simple as that. AZs are within the country, within a single country, within the vicinity of 100 miles. Okay, I'd like to know what are the challenges for the ETL solution providers to release their products for the cloud at the same time, especially IBM products such as data storage. So when I talked about marketplace, all these technology providers they have their solutions available on marketplace, and I'm sure Cloudera, Hortonworks, MapR, every cloud provider is there. Even I would say the competitors like Microsoft, they have their workloads, so their databases, Oracle, their databases, their ERP systems, right? Microsoft, their Active Directory, App Dynamics. So even the competitors are also competing on cloud, but they still kind of are available on multiple platforms. So I don't think it is right to say that these are not available. It's just that you'll have to see what products. I'm not sure about IBM especially, okay, but I see that even Microsoft and Oracle, which are kind of competing against AWS, but still they have their softwares available as part of the marketplace. Or in fact, Microsoft is fastest growing vertical within AWS. So Microsoft workloads, they are kind of 100% year-on-year growth adoption, right? So both are completely different. I mean, software and infrastructure, they are completely different, and they kind of integrate. I would say they share, or they're integrated on that front. How EPC and EC2 is different from private cloud? Does Amazon have a private cloud provision? No, Amazon does not have a private cloud. Amazon, in fact, VMware and Amazon has got together to offer V services, which kind of private cloud on AWS, right? So AWS does not, like I said, does not believe on private cloud. So that's why they do not have. So yeah, private cloud, no AWS, no, but they have partnered with VMware, and where VMware will be the face of the sales, and they'll offer the, yeah, private cloud. Thus, all availability zones have the same pricing, or yeah. So pricing is at a region level. So every region will have a different pricing. Not at a daisy level. It's at a region level. How did Bhavesh access? With the public IP. Okay. With the public IP, you access your web web workload on the server. How can get a static IP that won't change even after yet? So under VPC, there is something called as static IP, or even under EC2 on the left hand side, you can see static IP. You can provision it, and then you can associate with the server. Certification available and prerequisite, if any, on AWS certifications. All right, guys. So if you're talking about AWS certifications, I will just. So I'll just walk you through. So this is my website, cloudart.in. One kind of consulting and training is what I do. And when you talk about certifications, there are kind of two levels of certifications. One is at the associate level, you have architecting, developing, and system operations. And the other one is at the professional level, where you have advanced architecting and DevOps, right? So there are in total 5 certification, but if you're looking for AWS certification, you should focus on associate level first, either into architecting or developing based on what is your primary skill. If you're still a developer, then you should ideally focus on developer. And even architecting is a generic certification which gives you a breadth of the platform and how do you design a system, right? So I would say if you don't know which one to go for architecting. Yeah, if you are going to be in developing for a significant time, in career, then developing will kind of give you an understanding of how to build native cloud application, and system operations are for the people who are into ops, right? So these are the these are the certifications that are there. So initially you should target for the associate level, okay, which is architecting, developing, and sysops. Okay. So you can visit this website. I have some courses with the outline, and if you need any guidance, I can help you on that. So associate level certification has a cost of around 150 US dollar. That is, you have to directly pay to AWS and schedule your exam, which is on a Prometric like center. I think they've changed recently, and 65%, 65% is the passing cutoff. Okay. All right. No prerequisite for associate certification. Okay. All you need to have is learning and knowledge on how to work with AWS. Okay.
So, Bhavesh, we have covered all the questions. I would like to thank you a lot for taking this session. I'm sure that the students have found this session to be extremely helpful to them. And I would also like to thank Sandeep for taking up some time from his business schedule as well. So I hope that the students have found this session to be extremely useful. Please give your feedbacks. Bhavesh has already shared a link with you all, and we will also be sharing another link with you all, most probably on Monday. And tomorrow we will also be having a base camp at Mumbai. So people who will be attending this base camp will be seeing you tomorrow. And I would like to thank Bhavesh and Sandeep once again. Bhavesh, thanks a lot.
Thank you, guys. Always happy to help anyone on cloud. I mean, this is kind of more than a technology, a passion for me, and it really an amazing technology. It cuts across all the kind of verticals, be it a developer, be it a big data analytics, machine learning, and all right. And it's a good future. There is a good future in this, right? So glad to have with you guys today. Thank you so much, Shubham.
Thank you so much.
Thank you. Bye bye.
So the recorded version of this webinar will be available in the resources section within a day or two. And so I hope you like this webinar a lot. Please share your feedbacks when you will be sending in the feedback form. So see you in the next webinar.